Detroit, late 2002. Inside a crowded General Motors dealership service bay, three mechanics stood around a half-disassembled diesel pickup with grease up to their elbows and coolant dripping onto the floor. One of them slammed a wrench onto the cart and just stared at the engine. Not angry anymore, just exhausted. The truck had less than 40,000 miles on it. The customer was furious. The dealership was losing money, and the mechanics? They were starting to hate their jobs. Because buried under that hood was an engine so complicated, so failure-prone, and so brutally unforgiving that it pushed experienced technicians to walk away from the industry entirely. The service manager had already been out to the bay twice that morning, clipboard in hand, asking when the truck would be done. The customer was calling every 2 hours. Corporate was breathing down their necks about warranty labor costs. And the parts department had just informed them that 2 of the replacement injectors were back-ordered another week. This wasn't an isolated incident. Down the row, another bay had a nearly identical truck with the same problem, and another one was scheduled for Monday morning. But what almost nobody realizes is this engine wasn't supposed to fail. In fact, on paper, it looked revolutionary. Advanced, powerful, efficient. The future of diesel performance. Instead, it became one of the most infamous engines ever built, and the real story behind it is even worse than most people think. This is the story of the engine that made mechanics quit their jobs. The early 2000s were a strange time in the truck world. Diesel pickups were exploding in popularity across America. Farmers wanted torque, contractors wanted reliability, and suddenly, suburban truck buyers wanted something else too. Power. Not just towing power, street power. The cultural shift was massive. Diesel trucks weren't just work vehicles anymore. They were status symbols, performance machines, weekend toys that could haul a fifth-wheel camper on Friday and drag race on Saturday night. Magazines featured diesel trucks on their covers. Enthusiast forums exploded online. Aftermarket companies started developing performance chips that could add 100 horsepower with a simple plug-in module. Ford had the legendary 7.3 Power Stroke. Dodge had the Cummins Inline-6. GM, meanwhile, was getting crushed in the diesel performance war. Their old 6.5-liter Detroit diesel V8 simply couldn't compete anymore. It was outdated, underpowered, and constantly criticized for weak blocks and overheating problems. Truck buyers openly mocked it. Dealerships struggled to move inventory. GM's market share in the heavy-duty segment was bleeding away month after month. GM needed a miracle. So they partnered with Isuzu and created a brand new engine family called the Duramax. And at first, it worked. The first generation 6.6-liter LB7 Duramax hit the market in 2001 with numbers that shocked the industry. A 410 55-inch bore, a 389-inch stroke, high-pressure common rail direct injection, aluminum cylinder heads, 4 valves per cylinder, a variable injection system operating at over 23,000 psi. Back then, those numbers sounded futuristic. The LB7 produced 300 horsepower and 520 pound-feet of torque. In 2001, that was massive, especially in a heavy-duty pickup. Motor Trend called it the smoothest diesel ever installed in a pickup. Owners loved how quiet it was. Compared to the clattering old diesels of the 1990s, the Duramax felt refined. Fast even. Test drivers couldn't believe how much the diesel landscape had changed. You could actually have a conversation at idle without shouting. The engine pulled smooth and strong from 1/500 RPM all the way to redline. Throttle response was instant compared to the laggy turbo systems of the past. A stock Silverado 2500 HD with the LB7 could run the quarter mile in the mid-16-second range. That may not sound impressive now, but for a 7,000-pound truck in 2001, it was a rocket ship. Sales took off immediately. GM finally had a competitive diesel engine. Customers were excited. Dealers were happy. But there was a problem. Actually, several. And they were buried deep inside the engine. At first, dealerships started noticing strange symptoms. Hard starts, excessive smoke, fuel dilution in the oil, random misfires. Customers complained about rough idle and loss of power. The symptoms were inconsistent. Some trucks ran perfectly for months, then suddenly developed issues overnight. Others showed warning signs from the first few thousand miles. Diagnostic trouble codes weren't always helpful. Sometimes the check engine light never even illuminated. Mechanics found themselves chasing ghosts through fuel pressure readings and cylinder contribution tests. Then the injector started failing. catastrophically. The LB7 used Bosch common rail injectors mounted underneath the valve covers. That decision alone would become a nightmare for mechanics across North America, because replacing them wasn't simple. To reach the injectors, technicians often had to remove the upper valve covers, fuel system components, wiring harnesses, and countless brackets buried under layers of cramped engine packaging. In four-wheel drive trucks, access became even worse. The front differential sat directly below the engine. Steering components blocked access from underneath. Some mechanics had to remove front bumpers, skid plates, and intercooler piping just to create enough working room. And the injectors themselves were fragile during removal. Mechanics had to be incredibly careful not to damage injector tips or contaminate fuel passages with debris. One small mistake could turn a warranty repair into a catastrophic engine failure. Some mechanics estimated injector replacement jobs could take 12 to 16 hours flat rate. And here's where things got ugly. The injectors weren't just failing occasionally. They were failing constantly. Fuel would leak internally through cracked injector bodies and worn ball seats. Diesel diluted the crankcase oil. Oil levels mysteriously rose. Bearings began wearing prematurely. White smoke poured from exhaust pipes. One GM technician later described opening drained oil pans that smelled more like diesel tanks than engine oil. Some owners reported checking their dipstick on Monday morning and finding the oil level 2 quarts higher than it had been Friday afternoon. That's not a typo. The oil level went up because diesel fuel was diluting the crankcase faster than the engine consumed oil. Customers came back angry. Then they came back again and again. Some trucks needed injectors before 60,000 miles. Others needed multiple sets. There were documented cases of trucks receiving 3 complete sets of injectors before 100,000 miles. Each time, the customer lost their truck for days. Each time, dealerships absorbed labor costs that barely covered expenses. Each time, mechanics spent entire weeks doing nothing but Duramax injectors. Dealerships were drowning in warranty claims, and mechanics were the ones stuck in the middle. Most people don't realize how dealership flat rate systems work. Technicians don't get paid hourly. They get paid by the job. If a repair is listed at 10 hours and takes 20, they lose money. And the Duramax injector jobs were eating mechanics alive. The warranty manual might have listed injector replacement at 8 hours. But in reality, with access issues, frozen bolts, stripped threads, and parts delays, these jobs frequently stretched into multi-day ordeals. Meanwhile, the mechanic in the next bay doing brake jobs and oil changes was making twice as much money in half the time. One former GM diesel tech reportedly said, "You'd see an LB7 pull into the bay and your entire day was ruined." Some dealerships tried rotating the work to spread the pain around. Others assigned specific technicians to diesel repairs, which meant those mechanics bore the brunt of every failed engine that rolled through the door. Morale collapsed. Experienced techs started looking for jobs at independent shops or different dealerships. Some left the automotive industry entirely. But the injectors were only the beginning, because emissions regulations were tightening fast, and that pressure created an engineering arms race that would push diesel engines into dangerous territory. By the mid-2000s, every manufacturer was scrambling to meet stricter EPA standards. Nitrogen oxide emissions had to drop. Soot had to drop. Noise had to drop. But customers still demanded more horsepower. So engineers started cranking up injection pressure, turbo boost, EGR flow, and combustion temperatures all at the same time. It was like trying to run a marathon while breathing through a straw. And then came the real nightmare, the 6.0-liter Power Stroke. Now technically, Ford built it, Navistar engineered it, but among mechanics, the 6.0 became something else entirely, a career-ending machine. Introduced in 2003, the 6.0 Power Stroke replaced the beloved 7.3. Expectations were enormous. Ford promised cleaner emissions, better throttle response, and more power. The marketing campaign was aggressive. Television commercials showed Super Duty trucks hauling massive loads up mountain passes. Print ads highlighted the advanced technology and modern design. Ford dealers prepared for a diesel revolution. The specs sounded incredible. A 3.74-inch bore, a 413-inch stroke, variable geometry turbocharging, high-pressure oil-actuated injectors, an advanced EGR system, 18:1 compression ratio. Output jumped to 325 horsepower and 560 pound-feet of torque. At launch, it was one of the most powerful diesel pickups in America. And for a brief moment, it looked unstoppable. But beneath the impressive numbers sat a collection of engineering decisions that would haunt mechanics for years. The first major problem was the EGR cooler. To reduce emissions, exhaust gases were routed back into the intake system through a cooler designed to lower combustion temperatures. Sounds simple enough, except the engine's oil cooler frequently clogged with debris and casting sand left inside the cooling system. Once coolant flow dropped, EGR cooler temperatures skyrocketed. Then they ruptured. Coolant entered the intake. White smoke exploded from exhaust pipes. Head gaskets began failing under excessive cylinder pressure. Trucks overheated on the highway. Owners watched temperature gauges climb past the red line while towing fifth-wheel trailers uphill in summer heat. Some didn't even realize anything was wrong until steam started pouring from under the hood. And when those head gaskets failed, things got expensive. Very expensive. Because the 6.0 used only 4 head bolts per cylinder. At high boost levels, especially under towing loads, cylinder pressure literally lifted the heads off the block. Coolant sprayed everywhere. Dega bottles puked steam. Owners watched temperature gauges climb while hauling trailers uphill. Mechanics quickly learned the ugly truth. Stock trucks were blowing head gaskets. Tuned trucks were grenades. One diesel shop owner reportedly joked, "The factory torque to yield head bolts were basically decorative." But replacing those gaskets wasn't easy. The cab often had to come off the truck. That's right. Entire truck cabs lifted into the air with hydraulic shop lifts just to access the engine properly. The process was brutal. Disconnect the wiring harnesses, remove interior components, unbolt body mounts, disconnect steering shafts and brake lines. Carefully lift the entire cab assembly off the frame while the engine remained below. Only then could mechanics properly access the cylinder heads, replace gaskets, install upgraded head studs, and reassemble everything. A proper head gasket job on a 6.0 Power Stroke could easily exceed 30 hours of labor. Parts costs ran into thousands of dollars. Total repair bills sometimes exceeded $6,000 to $8,000. Imagine doing that multiple times a week. Now imagine customers screaming at service advisors while warranty departments fought over labor reimbursements. And then imagine trying to survive financially as the technician stuck doing the work. Many couldn't. Some diesel techs simply left the trade. Forums from the mid-2000s are filled with exhausted mechanics talking about burnout, endless warranty jobs, and collapsing morale. One technician wrote, "I got so tired of 6.0 head gaskets that I switched careers." Another posted about spending entire summers doing nothing but cab-off repairs. 12-hour days, 6 days a week, wrists aching from impact wrenches, backs destroyed from leaning over engine bays, all while watching their paychecks barely cover expenses because warranty times were impossibly optimistic. And then the turbocharger started sticking. The 6.0's variable geometry turbo used movable vanes to improve low-end response. In theory, brilliant. In reality, soot buildup caused vanes to seize. Drivers experienced overboost, underboost, lag, surging, or complete turbo failure. At the same time, high-pressure oil pumps failed. STC fittings cracked, dummy plugs leaked. FICM modules fried themselves from heat and vibration. No start conditions became legendary. Some trucks cranked endlessly without firing because injection control pressure dropped below operating thresholds. Mechanics spent hours chasing microscopic leaks through high-pressure oil rails buried deep inside the engine valley. The diagnostic process required specialized tools: high-pressure oil system testers, digital pressure gauges, factory scan tools that cost thousands of dollars. And even with all that equipment, pinpointing exact failure points sometimes took days. And the diagnostic process itself became torture. One mechanic described it perfectly. You'd fix one issue, start the truck, and immediately discover 2 more. But here's the crazy part. When the 6.0 worked, it was incredible. The variable geometry turbo gave it brutal low-end torque. Tuned versions easily made 450 horsepower. Some pushed beyond 600 with upgraded injectors and head studs. Street races between modified diesels became a phenomenon in the mid-2000s. 4-door trucks weighing over 8,000 pounds were running 13-second quarter miles while towing trailers during the day. YouTube channels dedicated to diesel performance started appearing. Truck pulls drew massive crowds. The aftermarket exploded with turbo upgrades, fuel systems, and transmission builders specializing in handling 4-digit torque numbers. The potential was there. The foundation just wasn't strong enough. And then things escalated even further. In 2007, emissions regulations tightened again, and manufacturers responded with diesel particulate filters, more aggressive EGR systems, and even higher combustion pressures. Engines became rolling chemistry experiments. The 6.4 Power Stroke arrived with compound turbochargers, piezo injectors, and 350 horsepower. But fuel dilution problems became severe. Some trucks literally regenerated soot filters by dumping raw fuel into the exhaust stream. That extra fuel sometimes washed down cylinder walls and contaminated engine oil. Oil that should have lasted 10,000 miles was breaking down at 3,000. Oil analysis reports showed fuel dilution percentages that made engineers wince. Bearings suffered. Pistons cracked. Turbos failed. One fleet manager reportedly said maintenance costs doubled overnight. Meanwhile, dealership mechanics were drowning. Specialized scan tools, constant software updates, endless emissions diagnostics. Customers angry over downtime and repair bills. The simplicity of old-school diesel engines was gone. Back in the 1980s, a mechanic could diagnose many diesel issues with basic hand tools and experience. Listen to the engine, check injection timing, monitor boost pressure. Most problems had mechanical solutions. By the late 2000s, technicians needed laptops, pressure transducers, wiring diagrams, oscilloscopes, and factory subscriptions just to diagnose intermittent faults. Training requirements exploded. Mechanics attended week-long certification courses just to stay current on diagnostic procedures. Technical service bulletins arrived weekly with updated repair procedures and software calibrations. And that changed the industry forever. Shops struggled to retain experienced technicians because the stress level became unbearable. Young mechanics entered the trade excited about horsepower and heavy machinery, then found themselves trapped in endless warranty repairs on emission systems nobody fully trusted. The pay structure didn't keep pace with the complexity. A diesel tech in 2008 might have made slightly more than someone working on gasoline engines, but the knowledge requirements had tripled. The stress had quadrupled. But perhaps the most brutal part of this story is that many of these engines were victims of impossible demands. Think about it. Customers wanted 800 pound-feet of torque. They wanted silent operation, clean emissions, better fuel economy, massive towing capacity, cold weather reliability, long service intervals, lower costs. And governments demanded near-zero emissions at the exact same time, so engineers kept stacking complexity onto already stressed platforms. More boost, more heat, more pressure, more electronics. Something had to give. And often, it was the mechanic. Because mechanics absorb the consequences of every rushed engineering compromise, every inaccessible bolt, every fragile gasket, every under-tested emission system, every unrealistic warranty labor time. They were the ones bleeding knuckles at midnight trying to extract a seized turbo bolt. They were the ones explaining to furious customers why their $60,000 truck needed another $5,000 repair. They were the ones sacrificing weekends and family time because warranty backlogs stretched months deep. By the early 2010s, many independent diesel shops had entire business models built around fixing failed Power Strokes and Duramaxes. Bulletproofing became a real industry term. Aftermarket companies sold upgraded EGR coolers, ARP head studs, revised oil coolers, stronger FICM modules, and redesigned injectors specifically because factory parts failed so often. Entire conferences emerged where diesel shop owners shared repair strategies, parts sources, and survival techniques. Online communities developed detailed guides for bulletproofing procedures. Some shops offered complete packages priced at $10,000 to $15,000 that essentially rebuilt major engine systems before they failed catastrophically. Some owners spent $10,000 to $20,000 repairing trucks they still loved. Others gave up entirely. Trade-in lots filled with low-mileage diesel trucks, carrying mechanical baggage that destroyed resale values. Some owners just walked away from financing, unwilling to pour more money into vehicles that felt like endless money pits. And yet, despite all the pain, these engines became legends. Why? Because they represented a wild moment in automotive history where manufacturers pushed diesel technology to the absolute edge. The LB7 Duramax introduced high-pressure common rail systems that transformed diesel performance forever. The 6.0 Power Stroke pioneered turbo technology and tuning potential that shaped an entire aftermarket culture. These engines failed spectacularly, but they also changed the industry permanently. Modern diesel pickups making 500 horsepower and 1,200 pound-feet of torque owe part of their existence to the brutal lessons learned during that era. Today's engines use stronger head-clamping systems, improved cooling designs, revised injection strategies, and vastly more advanced diagnostics because manufacturers survived those disasters. Current generation diesel trucks are genuinely impressive machines. They start instantly in sub-zero temperatures. They tow massive loads while meeting strict emissions standards. They run 200,000 miles with proper maintenance. But ask almost any veteran diesel mechanic about the mid-2000s, and you'll probably get a long stare followed by a painful laugh. Because for them, these weren't just engines. They were stress, burnout, lost weekends, destroyed knuckles, warranty battles, midnight cab removals, endless injector replacements. They were the engines that made mechanics quit their jobs. And maybe that's the strangest part of this whole story. These engines were designed to make trucks stronger, but the people forced to repair them, they were the ones who broke first. If you enjoyed this story, let me know in the comments which engine nightmare you want to see next. The North Star, the rotary disasters, or another forgotten mechanical catastrophe. And make sure to subscribe so you don't miss the next deep dive into the machines that changed automotive history forever.